once again, we have a unit circle with a radius of 1 that we're going to be looking at, and we're going to be looking at the special triangles in relationship to the unit circle. Once again, if the unit circle has a radius or a hypotenuse value of 1, I would need to divide each one of these by 2 in the 30, 60, 90 triangle to get the sides of the triangle. So we have one side of the triangle becomes 0.5, the other 0.87, and the hypotenuse is 1. Similarly with the 45, 45, 90 triangle, if I made this into a triangle with a hypotenuse of 1, then I would end up with 0.71 as the length of the sides. So looking at the horizontal side now, so let's put in our 30-degree angle. And we talked about this in the sine video, that the horizontal side right here has a length of 0.87 units and the vertical side 0.5, just like we see right here. Since I'm focusing in on the horizontal side, I'm going to label my horizontal axis. This would be 0.2, 0.4, 0.6, 0.8, and 1. So cosine of 0 is equal to 1. That's our first value. Now if I were to draw, so what I'm going to do here is think about, let's draw all the way over to here is 1. Okay, so there's my cosine value. Now let's look at 30. 30, the x value we saw down here as the base of the triangle, but if I keep drawing triangles for each one of these, I'm going to end up with all the bases on top of each other. So let's just think about this as the coordinates of this point. The coordinates, the x coordinate of this point is 0.87 and the y coordinate is 0.5, and I want to focus in on the cosine value, which is the x coordinate. So the x coordinate of this point is the distance from the y-axis to this place where 30 degrees intersects the unit circle. So this is 0.87. So we went from a distance of 1 at 0 degrees to 0.87 at 30 degrees. Then when we get to 45 degrees, this x distance is now just 0.71. So this is x equals 0.71. And then when we get up to 60 degrees, x equals 0.5. Now, going into quadrant 2, we have negative 0.5, negative 0.71, negative 0.87, and negative 1. So we see our our y values going, our x values now going positive and negative, but the same length each time. So for my cosine, I start out with at 1. At 0 degrees, I'm at 1. At 30 degrees, 0.87. At 71 degrees or 45 degrees, 0.71. At 60 degrees, 0.5, and at 90 degrees, 0. So I have this curve going downward as the size of those adjacent sides. Okay, so I'm going to put the y-axis in here so we can kind of divide this in half. So I'm moving from these points outward to each of the angles. Okay, so this is where I'm getting these distances all the way out. So I'm moving out 0.1, 0.87, 0.71, 0.5. And those correspond with the adjacent side of the, excuse me, the adjacent side of the triangle in standard position. Now, going down into quadrant 2, I'm going to go negative now. So 120 has a cosine value of negative 0.5. Go ahead and stick with black. 135, negative 0.71. 150, negative 0.87, and 180, negative 1. So that's quadrant 2. Now notice when I get into quadrant 3, I still am negative. So negative 0.87, negative 0.71, negative point, oops, a little too high. Let me erase this. Negative 0.5. So negative 0.87, negative 0.71, negative 0.5. A repeat of what I just did in quadrant 3. So I'm kind of going back, negative 0.87, negative 0.71, negative 0.5, and then I'll end up at the bottom, 0. Because there is no adjacent side when we're straight down. And then going back into quadrant 4, positive 0.5, positive 0.5, positive 0.71, positive 0.87, all the way back to positive 1. So 0.5, 0.71, 0.87, back up to 1. So here is the rest of the graph. So notice that the cosine, the y value of the cosine graph tells you the length of the adjacent side of every triangle that you could draw in a unit circle. Now let's take a look at special points that make this easy to graph. I want to look at, of course, the highest point, which is at 0 degrees. At 90, we're at 0. At 180, negative 1. At 270, we're at 0 again. At 360, we're at positive 1. So negative 1 is the lowest value, positive 1 is the highest value, and we have high, middle, low, middle, high at those 5 key angles. Now the other place that's really nice is when we're at negative 0.5 or positive 0.5, and those are going to occur here, 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 and here. Now notice these angles, 60, 120, 240, and 300. These are the 4 angles that all have 60 as their reference angle. So cosine of theta is equal to positive or negative 1/2 at all angles with a 60-degree reference angle. Now I know I went very quickly while plotting the points, so I encourage you to go back and slow down and watch again if you need to have to work on plotting the points. But from now on, once you get the basic shape of the graph down, the key points that you need to know are the high, middle, low, middle, high, and then the values where it equals 1/2. The other ones, once you have those points, you'll be able to draw the graph easily without any other points.